Yeah, hello, welcome to demonstration over for kit. Previously we have seen just a node transferring of data. Now this is whole our kit where I can show you, and I have extended this project for IOT event. So think this is a cloud. So actually we just want to make extension of the LDR data which the nodes. So here you can see two nodes, two LCDs. So I'll show in zoom over here. Let us give overview, then I'll go in zoom. So these two nodes are taken as the nodes, that is this is inside sensor and that is a outside sensor, so which are providing data through the Zigbee's provided here. And this is our ARM7 processor, which consists of again Zigbee module, which receives and operates the light provided, the LED lights provided over here. And what I have extended over here is we can also control the PWM not only based on automatic values, also by manual. So I connected my CPU to the ARM7 kit, and also we made such as, why can't we take the sensor data and push it to the cloud? So here I used one Wi-Fi module attached to Raspberry Pi, that is ESP8266, and through that I am providing it to the server. So I had a web service over in my room. So if you have internet, which we have to provide access through hotspot. So I just provided the hotspot, and now let us see the execution part. So first let me show the discussion. Let me give description of the kit, and then I'll go how manual controlling, and then I'll show how the data will be uploaded into the cloud using a other mobility device. So you can see this laptop is a mobility device, and this is what the inside device. Think that. Let us go over here. Fine. So if you see a single node over here, so which consists of an LDR sensor and AVR controller, that is 8-bit, and which is providing data through the Zigbee. So to verify whether the LDR value is working or not, here we provided LCD. You can see if I close the, if I make the LDR to dark, the value gets decreased and value gets increased. In the same way, here we provided one more LDR. So this is one more node. Think this is an inside node and that is the outside node. So when LDR value is closed, then open, you can see the variation in the LDR. Okay, fine. So first what you do is just plug in the RS232 cable, either if you have CPU or if you have laptop, you want to use USB to RS232 conversion. And as you know, we have to open the Proteus, which I have shown you in the last video. Then first plug in for node 1 and node 2, means provide the power supply for node 1 and node 2. Then go for providing power supply for the central node, that is the access node. Now you can see the access node consists of a, so think this is a internal lighting and this is a external lighting LED lights. And then we had the ESP8266 Wi-Fi dongle over here, and this is a Zigbee which receives the data from two nodes, and this is what our ARM7 processor. And this relay is used for tripping of UART. So this is not used for controlling. Actually I need to control, I need to interface this ESP8266 and PC to a single UART. So I have used a relay over here. Let us see the execution. So now after switching all this setup like this, So first provide power supply for nodes, and then connect the RS-232 and open the UART serial terminal, and then now provide the power supply for the ARM7. Please be sure for making the connections. Now let us provide the power supply. When you provide the power supply, you can see LEDs gets blinking. So based now the data of the LDR will be taken for every 1 minute. So be hold, because when you switch on, first the ARM7 will characterize or configures the ESP8266. You can see a blue light blinks over there, then it is working on. And then this is I think this is an internal circuit, the internal LED, and this is an external LED. So it goes on working. So let us make this dark. So please behold, so here I am just providing the light, and I'll show how it works automatically. Yes. Now let us see execution of that. So after connection, so sorry for pause, basically just I required the power supply to set up, so I just pause this, and then let us continue the video. First just switch on the power supply of 2 nodes, then connect the RS-232. So now be sure that I am just showing the manual and automatic control through internal server, or think internal PC. That's it. So let us go with that itself. So this is internal, let us think outside LED lamp, and this is inside LED lamp. So now after connecting after providing power supply for 2 nodes, and after providing power supply for ARM7 and connected RS-232 to your PC, now what you need to do is, you can see the updates will be coming on this. So for every 5 seconds the LDR, sorry, for even not even 5 seconds, for every 2 seconds LDR gets data, and the light dimming will be done. So basically when you switch on, it will be in automatic mode. So I'll make it reset, and I'll show you. When you just reset, and now you can see the LDR is normal. So I'll apply light on the LDR. Now we can see the LED over here is lighting on. So I'm just applying LDR for the light. I think that is a sunlight. So you can see it gets dim. And you can see when I close it, it gets fully brightened. Okay, so in video you can't find the, because it goes on toggle, so you can't find that lighting. You can see it practically. Observe slight variation. Yes. Okay, so this is automatic mode, and let us see how to control this manually. Go to your PC where you will be having TXT window. There press capital M first. Capital M first. Then it makes into manual, which indicates. Now press 5, 6, 7, 8 and 1, 2, 3, 4 for controlling. So I'll be pressing 1, 2, 3, 4. Just look at the LED. 1, 2, 3, 4. You can see that the first LED lamp gets vary. So when I type 1, 2, 3 and 4, and next for second LED 5, 6, 7, 8. For 5 it gets completely off. 6 somewhat high, 7 somewhat high, 8 somewhat high. So now it won't work based on LDR because we have changed it to manual mode. Again, if you want to work with LDR, just convert it into automatic by pressing capital A. Now it will be working based on again automatic mode. Now you can see, please place the light. Now you can see it gets variation when I place right, and when I place hand it gets vary, and you can see the values will be updated over here. So in this way, this is how to show manual and automatic mode. Next, let us show how this sends the data to the cloud using Wi-Fi. So for this we need to make small setup in your configuration of the internet router. So basically the router should be configured, or if you doesn't have router, you can make your laptop as hotspot which having the internet and place the settings like this. So basically to connect that, I have written ESP8266 works based on the commands. Those commands will be given in the ARM7 code which is provided for you. So the code I have written, these are the 80 commands. So basically ESP8266 works with the 80 commands, 80 reset, 80 CM mode and everything else. But what about internet? So to get internet we have to provide SSID and password of the internet service provider. So here I am getting the here I am using a Reliance Wi-Fi modem. So the SSID of my modem is this and the password is this. So I can set this through the code dumped in the ARM7. Now when you are executing, you doesn't have this modem. So what you do is better make your mobile or anything hotspot and make that SSID to be this and password to be this. You got it? Nothing but the router or the modem or the internet providing for you should be changed to the SSID as Reliance Vipod 63 and make the password of that as SUDH1925. Fine. Then after, how to monitor the in the web. So the Wi-Fi modem is providing the data to this website. So I'll be providing this link for you in the documentation. So just click this link over there and then you'll get the monitoring session like this. Just a minute. కొంచెం హెల్ప్ చేయగలవా? అది ఓపెన్ చేయండి. Now you can see this is a monitoring section where I have placed LDR1 and LDR2. So I created two graphs. So basically this is a ThinkSpeed IoT cloud which can take the data provided from the end node and makes a graph like this. So in this way we can show the output. So as this is a mobility device, you can show this just open that link in any mobility device, nothing but your Android phone or anything else. So in this way we should execute the project. And thank you. So this is what, so this total execution I am just explaining overall. We can control manually and we can control automatic based on nodes of the LEDs, and also this can be pushed into the cloud. So this is whole our scenario. I think fine. Thank you and keep doing it.